So hello everyone, and today we'll learn about arithmetic sequences. So I think everyone has seen on the TikTok that there is some kind of puzzle where it says what is the next number in series, and then you have the following numbers. You have 3 that jumps to 6, 6 to 9, 9 to 12. And I'll give you a few seconds to think about it, and then I'll show you how to do it. So I think you have figured it out how to do it, and you really have understood that it jumps by 3 each time. And you understand that here goes 15 because 15 plus 3 is 18 and plus 3 is 21. That's exactly what arithmetic sequence is. And the main arithmetic sequence formula is UN equals U1 plus n minus 1 times d. This might seem a bit confusing at first, however, if I explain it, you'll definitely understand. So U1 is essentially the starting point. It means that this is the start of your series, and if you're given a huge set of numbers, like here, 3 is the U1, it's the start of your series. The D is the common difference, and because I'll write it, common difference. And because of this, D shows a constant change. And if D is positive, it means that something is going constantly up. And if D is negative, it means that something is going constantly down. And n is the number of nth series, meaning that n is the number of terms, and usually it's a time period as well. If it still seems confusing, don't worry, I have brought a very great example to show this in a much more easier way. So let's say that we have a tree, and when the tree is planted, we know that it was planted when it was 1 meter tall. And we know that the tree grows by 4 meters every year. Therefore, we can really understand that this is an arithmetic sequence. And if we go back, let's say that we know that the question asks us that what is the tree's length in the 7th year? Then we understand that n is 7. So essentially, n in most cases is the time frame. And then you can just plug in your data. You can put that UN equals U1, which is 1, plus n minus 1, and n is 7, times 4. And you can plug in your data. To get that in the 7th year, U7, the tree is 25 meters tall. And then you have to write it out as a full answer as well. However, the IB exams would be way too easy if you just had to plug in info into your calculator. Therefore, I will show you a problem that will actually be something that will be on the IB exams as well. And you can I'll give you 3 seconds to read, and then I'll read out loud as well. So, the number of kids entering a park can be modeled by an arithmetic sequence. It is known that in the first hour the park was open, there were 50 kids. And in the last hour of the park being open, also known as hour 8, the amount of kids had quadrupled. Find the amount of kids entering the park every hour. So we know that the amount of kids entering every hour is constant because it's an arithmetic sequence. So we can really get from this text is that U1 is obviously 50. And it said that in the last hour, hour 8, the amount had quadrupled. Therefore, we can put that U8 equals 50 times 8. 50 times 4. equals 200. And then it said that you have to find the kids, amount of kids entering the park. And it's very simple that we're searching for the common difference. So we can put this as a question mark. And then we can do the same formula again, that un equals u1 plus n minus 1 times d. And then you can find from here that 200, which is our u8, equals 50. And since we're looking at 8th power, it's 8 minus 1 times d. And d is not what we know. And if you're new to IB, then I suggest you click on Math and Numerical Solver. A numerical solver is one of the best functions because it just does the math for you. So you can put in 200 equals 50. I've done something similar here. And instead of d, you put x. And x can be found here as well. So, and then you get your answer. That d equals to 21.24. And then you round to 3 significant figures, and you get that the amount of kids entering each hour is 21.4. But however, there's 2 parts to the arithmetic sequence, and the other part is the sum of arithmetic sequence as well. It actually seems very easy, and if you start to think of sum, you most likely already know what it is. You will kind of start to understand that it's just u1, u2, u3, and more. However, sometimes when there are too many terms, there is no need to just add them all up, and you can just stick to 2 formulas that are also in the booklet. So let's start with the first one. The first one is relatively more shorter and more complex, and it's just Sn, which is the sum of arithmetic sequences, is n divided by 2, u1 plus un. And in this case, it's kinda understandable, as we already talked about this, that u1 is the first term and un in this case is the last term. This is something very important because some people, they still use wrong terms even though when it's shown. So for example, let's say that we're looking for people entering a movie theater. So let's say that we know that in the first hour there are 20 people who entered the movie theater, and in the 5th hour, which was the last hour that people were entering, there were people who entered were like 30. And in this case it's actually very easy because we just plug in our data. And I don't think I have to do this because it's the same as before. However, when you're not given the last term, there is no need to worry, because if you're given something else, like for example the d, then you can also do it. And then you have to stick to the other formula, which is Sn equals n divided by 2, 2 times u1 plus n minus 1 times d. And let's try to find an example for this as well. So let's say that we know that there is a movie theater, and 10 minutes before the show, people start coming in. And the first minute that people are coming in, only 5 people came in. However, in the last minute, we know that 200 people came in. And therefore, here we can use the first formula to understand that the total of these 10 minutes, we can just divide 10 by 2, and then we stick to the formula, put 5 plus 200. Then we can put it quickly into our calculator. And we get that the total within the 10 minutes of people coming in was 10,025. And however, let's say that there's not given that in the 10th minute there's 200 people. Then we have to resort to something else, and let's say that we know that still the first minute the people came in were 5, but let's say that each minute 30 more people came in. And then we can just stick to the other formula that says that S10, because we're still searching for the 10 minutes, equals to 2 times 5, because it's the booklet. You can also check it. I will put it up for you. And plus n minus 1, which in this case is 10 minus 1, times 30. And you will also get a similar answer. Where is this? Which will be 2 times 5 plus 9 times 30. And you will get that total here will be 280 people who came in within that time. Thank you.